Now let's look at the empirical approach and what it has to do with the law of large numbers. When we're using the empirical approach, we obtain an approximation instead of an actual value. And as the number of observations or the number of repeats of our procedure increases, the approximations tend to get closer to the actual probability. In other words, if we could calculate the classical probability, then the empirical probability would get closer to it as we ran more and more repeats of our procedure. And this is called the law of large numbers. So as a procedure is repeated again and again, the empirical, or the relative frequency probability, tends to approach the actual, or the classical probability. Here's an example. In the game of solitaire, the outcomes, or the hands dealt, are all equally likely, but the procedure is so complicated that calculating the probability of winning using the classical approach would be extremely difficult. So in this case, it's much easier to get estimates of the probabilities using the empirical approach. The approximations will be closer to the actual probabilities the more times the procedure is repeated. We can use a computer simulation of the game to get a large number of results, and the results can then be used to approximate the probability of winning. This would be much easier than performing all the complex calculations required with the classical approach. Here's another example. If we're rolling a die, the classical probability of each of the 6 possible outcomes is 1/6, or 0.1667 if we rounded to 4 decimal places. As we keep repeating the procedure, the relative frequencies of the outcomes, or the empirical probabilities, should get closer to our classical probabilities. So here are some results. If somebody actually went out and did this, here's an example of what they might have come up with. So for each of the 6 outcomes, we have the frequency listed, how many times that particular number came up on the die, and then we have our relative frequencies here. And notice that some of them are fairly close to our classical probability of 0.1667, but some of them aren't that close. For example, the 2 came up more times than we probably would have expected, so the relative frequency here is 0.22. But again, this was only 50 trials. That's not really very many repeats of our procedure. So if we do this again, when we do a lot more trials, say if we do 2,000 trials, so 2,000 rolls of the dice, record all of the results, then notice what happens to our relative frequencies. We still have some that aren't quite as close to the 0.1667, but they're much closer than they were when we only had 50 trials. So again, as we repeat the procedure, so if we kept repeating this and got up to 10,000 trials or 50,000 trials, the law of large numbers tells us that these relative frequencies would get closer and closer to our classical probability of 0.1667.